Welcome, math models, to estimating population mean. Before we get started on some examples, we're going to go over some vocabulary words. Sample mean, remember mean is the one where you add up all your data values and then divide by how many values you have. So sample mean is the average of just your sample. For example, if you survey 100 Temple residents to ask how much they spend on healthcare this year, your sample is just those 100 people. So the sample mean is just the mean of those 100 people that you talked to. Compare that to the population mean, which is the average of the entire population. In this case, if you surveyed those 100 Temple residents, your population is everyone who lives in Temple. So sample, just the people you're surveying. Population, everybody who lives in Temple. Usually when you're doing a survey or an experiment of some kind, you can't study the entire population in order to find the mean because it's just too many people. If we take this Temple example, we've got roughly 70,000 people in Temple. It would be prohibitively expensive and time-consuming to try to contact all 70,000 of these people, or at least the ones that are adults, and ask them how much they spend on healthcare the past year. You would have a bunch of people ignoring your phone calls, maybe throwing out your mailers. So because of that kind of thing, we use samples. Hence those 100 people or 1,000 people that you actually talk to. And we can estimate the population mean with your survey data. So we can estimate the population mean if we know the sample mean and standard deviation. And then turn the page and we'll find out how. Let's jump right into an example. A sample of 1,000 Americans showed that they spent a mean of $9,580 on healthcare each year with a standard deviation of $450. Remember, this is how spread apart your numbers are. Smaller standard deviation means your data are closer together. Larger means they're farther apart. Estimate the population mean with a 95% confidence interval. Let's take a minute to talk about this. Go down to this picture. 95% confidence interval means that we're 95% confident, but not certain that the population mean is going to be between these two numbers. We're going to get a kind of give or take amount. In other words, we're going to figure out what's the population mean, give or take $100 or give or take $10 or whatever. So that's what we're going to have to figure out. You're going to use this formula to figure out your give and take. So this is called the margin of error. So that's your give or take amount. S stands for standard deviation. And N stands for the number of people that you surveyed or studied in some way. Okay, pause this if you need to so you can get all that down, and then let's look at the rest of the first example. First thing we need to do is figure out our give or take. What is that margin of error that we need to estimate our population mean? So, a sample of 1,000 people That's our N value. That's how many people, that's the number of people we talked to, 1,000. And then we know they spent a mean of $9,580. That is your X bar. And then your standard deviation is your S. Let's fill these values into this formula. And it's an approximately equal to sign because in reality the formula is about 1.96, I believe. We're rounding it to 2. So go ahead and put a approximately equal to sign. So take 2 times the standard deviation, so 2 times 450. Then divide that by the square root of the number of people you surveyed. The square root of 1,000 people. And that gives us about $28.46. So that's our give or take. Then, let me label that. So we're going to find the mean now, give or take, about $28.46. I'm just drawing a little mini version of this. Here's your mean in the middle, which was 9,580. And here we're going to be doing adding our give or take value, so adding the margin of error, and then subtracting the margin of error. So we're doing this basically, right there. So start with the 9,580 plus 2846. And that gives us $9,608.46. Then on this side, we're going to take the mean minus 2846. So I'm going to put that like this. 9,580 minus $28.46 gives us $9,551.54. That means the population mean, or mu, is between $9,551.54 and $9,608.46. So that means that on average, Americans spend between $9,551.54 and $9,608.46. So our population mean, as we're doing it, is always going to be a range, just like that. Population standard deviation, on the other hand, we're not going to calculate. However, it's always going to be less than the sample standard deviation, which is right there. No matter what, it's going to be less. And we're going to talk about why in class. I'm not going to put that in the video because I want to give you some more examples on that. But it's always going to be less than your sample. So population standard deviation is always less than whatever your sample standard deviation was. Okay, that's kind of a lot. So let's try a couple more. Example 2. In a sample of 100 Bell County residents, a mean of 4 school or work days were missed due to the flu, with a standard deviation of 1.6 days. Estimate the population mean with a 95% confidence interval. So we want to figure out, on average, how many days are missed because of the flu. So start with your margin of error. E is approximately equal to 2 times the standard deviation. And our standard deviation is 1.6. Divided by the square root of the number of people. The square root of 100 people. Put it down here, and we get about 0.32 days, give or take. That's our give or take. So when we have our mean, which was 4 days, they're going to be missing 4 days of school, give or take 0.32 days. Let's see what that comes out to. Here's our mean, x bar, which was 4 days. Then you're going to be adding 0.32 and subtracting 0.32, which gives us, this is 4.32. This is 3.68. So we figured out, on average, people are missing anywhere from 3.68 days to 4.32 days on average. So our population mean, mu, is between 3.68 and 4.32. And our population standard deviation is always less than the sample standard deviation, so it will be less than 1.6. Remember, we're doing this because we're not going to go talk to every single person in Bell County. That's several 100,000 people. That would be pretty expensive and pretty hard to actually get everybody to respond, because a lot of people don't respond to surveys. So we take a sample and we do some math to figure out what our population mean will be. Example 3. I'm going to read it out and then I'm going to ask you to try to identify the parts of the formula. This time, a sample of 1,000 Bell County residents was conducted. They missed an average of 5 school or work days due to the flu, with a standard deviation of 0.9 days. Estimate the population mean with a 95% confidence interval. Go ahead and identify the parts first. Hopefully you said n, or the number of people, was 1,000. X bar was 5, and the standard deviation S was 0.9. Let's plug that in the formula. See if you know which formula is correct. Hopefully that's the formula you chose. 2 times the standard deviation divided by the square root of the number of people you surveyed. And then for this you get, we're going to go ahead and round it to 0.057. See if you can figure out the interval now. I'm going to start you off. Here's X bar. There's our sample mean, the mean of the 1,000 people we talked to. And then you're going to figure out the interval. See if you can do it. Your interval should have been 4.943 to 5.057 days. So on average, people in Bell County are missing anywhere from about 4.9 days to about 5.1 days. So right around 5 days. Our sample was actually pretty good. For our last part, see if you can figure out this part. The population standard deviation, sigma, has to be less than what? Hopefully you said that the population standard deviation is less than 0.9. And we'll talk more about why in class together. But for now, that's it for these notes. Thank you for watching.